This video will be reviewing the Vernier Spectral Analysis app. First, just to show you how to access this app, just enter the App Store and type in Vernier Spectral Analysis. It should come up, and it should be available probably regardless of your device, as it is compatible with Apple, Android, Chrome OS, or even Windows. So, yeah. So this app works by Bluetooth pairing to the Vernier Go Direct SpectraViz Plus. To do this, you just hold down the button, which turns it on, and then wait for the Bluetooth light to turn on as well. To connect the devices, just press the connect the spectrophotometer button. It's at the bottom of the screen right now. And as long as it's relatively close, it should come up as an option. But otherwise, you can also enter a serial number. So the lamp does take a little while to warm up and get ready to collect data. But if this is already like your second experiment and it's already warmed up, you can just press the skip button. Then you have to calibrate your lamp, and you just do this by taking a blank, which is basically like a cuvette filled with water, and you put it in just so it kind of calibrates, and then when it's all in and aligned, just press finish calibration. You then choose the wavelength of light you're going to use for your experiment based on which wavelength will get you maximum absorbance. I'll be using 410 nanometer light for this demonstration. So I know you can't see it right now, but what I'm doing is collecting data by simply putting the cuvette in the lamp, and then I press collect, and then it takes you to another screen, and then you press keep point, and that's how you actually save the data. And just know that once you save a data point, you can't really delete it unless you delete like all of your other data points. So just something to keep in mind. And I'm doing this for all 5 standards of known concentrations, as well as for the experimental group. While I'm doing this, I think I'll explain that spectrophotometers actually work by shining light through the sample and measuring how much of that light is absorbed by the sample or how much is transmitted through the sample. Because the absorbance has a direct positive correlation to the concentration and transmittance has a direct negative correlation. A standard curve with known concentrations can be used to estimate the concentration of any experimental samples. Now, the units for concentration are going to be default set to molarity. So if your experiment is like mine and your units aren't in molarity, then you can change it to whatever you need. And I'm just going to change mine to nanomoles per liter. These are the standards I'm using. So known concentrations, S1 being the most concentrated and S5 being the least. And this is also an example of a blank. This is where you actually put the cuvette in the spec, and you just want that little white arrow to be going through the sides without any ridges on it. Also, these are Kim wipes. They're just used to make sure the cuvettes are clean, and so that you get an accurate reading. And they're just extra good at getting all the oil and dust off. And it's also why if you're holding the cuvettes, you want to hold them from the top, not the bottom, because the oils from your hands are gonna get in the way and get you an inaccurate reading. I'll also be reviewing the transmittance setting of this app, and it's very similar. I'll just be going through measuring the transmittance of the 5 standards and then the experimental sample. And it should be noted that I'm going to use these to graph and make the standard curve so then I can estimate the concentration of the experimental samples.
These are the graphs I made from the data. You can see that this one is absorbance versus concentration. This one is percent transmittance versus concentration. And you can see that I made a standard or a line of best fit for the standard curve, and that helps me estimate, because this is the absorbance of the experimental sample, and we can just go use the line of best fit and estimate the concentration.
So the readings were actually very precise, giving pretty consistent readings for each sample. Besides a couple hiccups due to user error, like just as general rule, once you change the cuvette, don't collect data immediately. Just give it a little chance to adjust and give the correct reading. But other than that, yeah, the readings were pretty precise, and I was a little surprised. But yeah, other pros were just like it's a more accessible, portable, like cheaper alternative to laboratory standard spectrophotometry equipment, and it has a lot of different features and settings appropriate for different experiments. Cons, it can be a little complex because there are so many features that it can be a little complicated. Um, and then the graphing and data part of the app is kind of glitchy. So that's why I had to manually do the graphs because the graph wasn't really working on the app. But yeah, the data collection part and um, all of that is good. It's just yeah, you might have to do some graphing off of the app. So I'd say the rating for the app is like 3.5 out of 5 stars, maybe 4 out of 5. It's pretty good.